Hi, I'm James Berry. I'm the Deputy Chief Executive at the Property Care Association. For those who aren't familiar with us, we are a UK-based trade association of approximately 450 members, comprising a mixture of contractors, manufacturers and surveyors, which in the main deal with defects as a result of water in the built environment. So this is going to be a relatively short presentation where we'll be looking at future-proofing against damp and mould. But I'm going to start by looking backwards. We've known about damp for some considerable time. Vitruvius, the Roman architect, wrote in his 10 books of architecture from the 1st century BC about the consequences of damp and how to deal with it. Yet here we are some 2,000 years later on, and we're still talking about damp, and probably more so than we ever have done before. So the statistics that you've got on your screen now comes from a government report, well, the government response actually to the coroner's report into the death of young Arab Ishak. Now, I'm sure you're probably all familiar with the tragic offence up in Rochdale, but for those that aren't familiar, he was a young toddler that lost his life as a result of excessive exposure to mould in his Rochdale home, which is truly unforgivable, and we need to ensure that these things don't happen again. But the response outlines the extent of the problem with regards to damp and mould in English homes. And it estimates that the number of homes in England with damp and mould range from 4% to 27% of homes, which roughly equates to 962,000 all the way up to 6.5 million. So we're not talking small numbers. I actually think those figures are on the optimistic side as well. The NHS state that 1 in 3 homes is affected by mould, so we're already up to around 33%. But whenever I've done presentations or spoken to housing associations, etc., what we tend to find is that number is much closer to 50%. So we are talking a big problem, and it is still the primary cause of building failure. Now, I'm very aware of my audience who I'm speaking to today, and I suspect many of you are probably sat there thinking, well, damp and mould is a problem for older buildings. And I have a degree of sympathy for that argument. Here we have 2 properties located within 3 miles of where I live, outside Cambridge. And you've got one that was built approximately 120 years ago. And then you've got one on the right, which is a modern build, probably 2 years old. And I would quite happily argue that you could have the same family in both of those properties producing the same volume of water, and you could have a problem in one, but not in the other. And I suspect most of you are probably thinking, well, of course, it's the older building. Older buildings are notoriously damp. This one in particular is solid wall construction. It's not going to be as thermally efficient. It probably hasn't got any provision for ventilation. It's going to be harder to heat. So, of course, it's going to be the older property. But I would quite happily argue that actually we see just as many problems, well, we see a lot of problems in our new builds because they are high performance construction now. They are very well insulated, but they're equally airtight. So any moisture that's made in that property cannot be discharged out of the building unless the correct steps are put in place. So, and that is where we're going to look at now. But the other reality is the world is changing too. So I'm under no illusion. I've mentioned Vitruvius and you know the legacy of dealing with damp problems. And the world has changed. And even within recent years, the problem is getting worse. We're spending more and more time indoors. There's a lot of statistics banded around that we're spending up to 90% of our time indoors nowadays. And the pandemic changed the world as well. So we are now working from home a lot more. The more time we're spending at home, the more likely we are to create moisture in our home, the more likely that is to link to problems. Equally, the amount of moisture we're creating in our homes as well, not just the amount of time we're spending in our buildings, but equally, we are creating more moisture through showering. Gone are the days where you'd have a bath once a week on a Sunday before school, and you were lucky if you got to get in the bath first. Most people now are showering twice a day and creating more and more moisture. Drying clothes indoors was always seen as a bit of a taboo that was going to sort of lead to problems. But the reality is nowadays, almost everybody does it. So our buildings need to be able to deal with it. But equally, we're changing as a society as well. We are less practical people. So when it comes to maintenance and looking after these things, we tend to turn to specialists rather than being able to undertake that work ourselves. But the reality is, particularly with modern high-performance buildings, we need to be able to manage moisture that's in it. And for that, we turn to ventilation. So now let's consider ventilation. How well do we do ventilation? Well, this was a study that was produced in 2018, and it looked at 80 new build homes across 7 sites in England. Now, 55 of those properties had intermittent extractor fans, 25 had continuous running fans, and it looked at how well they complied with approved document F, which is means of ventilation. So it tells you how to comply with building regs as far as ventilation goes. So for those that aren't familiar with the terms that I've just used, intermittent fans or continuous fans, intermittent fans are essentially what you're probably most familiar with. They're the fans that for the majority of the time are doing nothing until they're told to operate. And that could be either via the user pulling a cord, turning the light switch on. There might, if they're lucky, be a delay. Or it could be that there's some form of humidistat function in there. So when humidity reaches a certain level, then they kick in. But either way, they are dependent on something or someone telling them to work. The market is now shifting towards continuous running fans. They are continually dealing with the issue. They work on a lower trickle rate, as it were. They tend to be quieter and more economical. So the market is tending to move towards continuous running fans. But of those 80 properties across these 7 sites, how many do you think complied with the building regs? Well, of course, the obvious answer, it should be that's the minimum standout set for every property that's ever built or newly built. But the reality is only 3 fully complied with the building regs. And this was a study that was released by what was the Ministry of Housing and commissioned by AECOM. And it's quite alarming. And how can we expect our buildings to be able to deal with the moisture generated if we don't provide an adequate provision of ventilation? Now, of course, there could be a number of reasons why they fail. It could be down to the provision of information. It could be down to flow rates. It could be that they just haven't notified correctly about the install of a ventilation system. But BISRIA tell us that poor quality installation of flexible ductwork is the principal cause of ventilation problems in domestic buildings. So here we have a nice schematic that come from the Domestic Ventilation Compliance Guide, which is a document that unfortunately is now obsolete, but it does prove quite a nice point. As far as flexible ducting goes, what you should be seeing is something akin to what's on the left. It should only be used for final connections. It should be pulled to 90% taut. There shouldn't be any bends or peaks and troughs and elbows in it because that will reduce flow rates. You should maintain the maximum diameter. And if it's going through walls, it should be sleeved, and it should be sleeved in a manner or pointing in a manner that any water that may condense in that ducting is going to run out of the property rather than running back down the ventilation system. The proposals to changing the building regs are actually being sort of more harsh on the allowance for use of flexible ducting. Of course, the installer unwittingly would always prefer to use flexible ducting because it's much easier to install. If you've got to use rigid ducting, you've got to do proper joins, you've got to make sure you've actually measured it, and it's just much harder work. What we tend to see is installs much like what's on the right there. So you've got lots of dipping troughs, squeezed through the walls, and that's really going to impede the efficiency of that ventilation system. What you certainly don't want to see is something that's akin to this. And it's probably not something that you're not unfamiliar with. It looks like it should belong on a 1970s Doctor Who set. It's not where the standard should be set, and that's a high-end ventilation system that is never going to perform as it's meant to. So as another example of the quality of ventilation installs, so here we've got an MVHR system. Again, for those that aren't familiar, it's a whole house ventilation system where it takes moisture out of the wet rooms and then brings fresh air into your habitable spaces. And what it does is it has a bit of a heat exchange element in there as well, so it will heat the air that it brings in as well. But in this instance, the occupants were complaining that they could smell sewage. And as you can clearly see, the waste stack vent was right next to the intake from the MVHR. So that just goes to show, another new build that we don't do ventilation particularly well. There is very little enforcement, unfortunately, when it comes to quality of ventilation installs. Now, I will concede this is quite clearly a picture from an install in an existing building, but I think it proves the point quite nicely. And the point I'm trying to prove is that unfortunately there is a lack of understanding about the role that ventilation plays. Now, most occupants perceive that if there is air coming in that is causing them a chill, or it's costing them more to heat the house, and there may be a small amount of truth to that, but they miss the bigger picture of why we need a good provision of ventilation. There is, of course, the humidity control aspect of this, but we also need a supply of fresh air for breathing. We need it for the dilution and removal of pollutants. We need air for fuel burning appliances, and of course, temperature control as well. But perhaps one of the biggest examples of occupants or anybody sort of having a lack of understanding of what a ventilation system or ventilation strategy is meant to do is trickle vents. All too often they are closed, and they play an important role in providing a good air exchange within a building. And that's not it. It's simply because they don't understand the benefits of having them. And of course, a ventilation system is only as good and will only work as long as it's maintained. So this was an MVHR filter that I took from a property that I looked at a couple of years ago. It was a high-end property, just a few years old. But in that time, the owner had no idea that he had to maintain that system. He had no intention of cleaning the filters, and that he was not made aware. And when we pulled the filters out, that was what we were confronted with. But it's not just the high-end MVHR systems that need maintenance. All ventilation systems require some degree of maintenance. The role ventilation plays in providing a healthy indoor environment is only set to increase. The Future Homes and Building Standards has recently been out for consultation. And the whole point of this new standard, which will be introduced by 2025, is to give us world-leading levels of energy efficiency and reduce carbon output. Essentially, what we're going to do is make our buildings increasingly airtight. We've already seen from what we've just looked at that we are not doing the bit that's getting the moisture out of the buildings very well. And as soon as we set that bar a bit higher, unless we compensate by improving quality of installs of ventilation, what we're going to end up with is a lot of damp and mould problems. Perhaps another consideration as well, should we be designing ventilation systems that are more flexible? The building regs at present make the assumption that there are so many bedrooms in the property and these are the flow rates you need to achieve. But should we be looking, rather than necessarily making it based on bedrooms, that we give some considerations to the volume of people in that dwelling and some degree of flexibility once it's in there, almost future-proofing. So if it's a single occupant, the level of ventilation could be reduced, but then if there's a sharp increase in the number of occupants, that can be increased, the flow rates can be increased to compensate accordingly. That way, If you have a single occupant and you are over ventilating the property, you've negated any of that carbon savings that you would have had anyway, any of those energy savings. So the point that I'm hoping to make on these few slides is we really need to make sure that we get ventilation right if we want to avoid a lot more damp and mouldy homes going forward. Of course, it's not just ventilation that we need to worry about. We are seeing climate change, and with climate change, we're expecting to see increased precipitation. There's been recent studies that tell us we are already 7% wetter than we were 40 years ago. But it just stands to reason. As temperature rises, the warmer air has capacity to hold more water, which means that we are going to have heavier and more rainfall. So what about our houses? How are they going to deal with sort of more rain coming down? If we think about how our houses deal with rainfall at the moment, essentially is through our guttering and our rainwater goods. But what about the capacity of those gutters? If we are seeing more rain coming down a lot quicker, do we need to increase the capacity of our rainwater goods? Of course, we need to think about things like water retention as well, so our water systems and rivers aren't overwhelmed. But these are all things that we need to consider. Of course, the inevitable consequence of too much rain is flooding, particularly flash flooding. Now, this was a study that came out very, very recently. It says a team of scientists has predicted that most areas in Cambridgeshire could be underwater as early as 2030. Now, that's a very dramatic heading or title. And there's a similar study, or the same study, looks at parts of London as well, and you'll get a similar map. But what essentially it's saying that parts of these, the county of Cambridgeshire particularly, but across the country, there'll be huge areas that will be below annual flood levels by as soon as 2030, which is quite alarming. And this is an area particularly which is seeing a lot of development. But what steps are we seeing being taken to mitigate against this risk of flooding? Because I don't think there's much being done, because I don't think planners are necessarily familiar with flood resilience measures. We had Storm Babette at the tail end of last year, and we had 2,000 properties flooded, and we're set to see that increase more regularly. So what precautions are we taking to protect against increased flooding? Or are we designing in more faults? So here we have a very nice detached property, and we have the front and back entrances for this property. The back entrance on the right there, you can see it is pretty much standard. Now, the front door, a nice wide front door there, and you can see it's got a level threshold. But what you can also see is you've got a property that's set in a recess. You've got that level access, and then essentially you've got a nice slope running down to that property. So any water that's going to run down there, and I also know this property sat on a bit of a slope anyway, where there's going to be a lot of surface water running off down there. But all that's going to do is run down to that property. There is nothing now to stop that water entering that property. Now, I can understand the argument for level thresholds. They're obviously good for accessibility. But what we're also designing in here is the perfect storm to some degree, because that's great for water to enter that property unimpeded. So are we designing our properties now in a way where they're no longer as robust to the entry of water as what they once were? Another example, slot drains. Let's be completely frank. Drains are pretty ugly. They're ugly, but they're functional. And this is an example of us trying to make something that's not very attractive, a little more discreet, a little less of an eyesore. But when you've got something like this, a slot drain, now I know this one was really well installed, and it went to a soakaway, which was located just off the photo on the right there. But it's not going to take a huge volume of water for that slot drain to become overwhelmed and probably enter that property as well. Other things to consider as well is that's going to need a lot of maintenance. It's not going to take much for that to become blocked. And then you also need to maintain it more regularly. And on one of the earlier slides, I spoke about how, as a generation or generations, we're moving away from being less hands-on people. We want to do less maintenance. We don't want to do this sort of thing, but that's going to require an increased amount of maintenance. Another example of style over substance, I guess. Now, I will concede, I know most of you are probably going to be looking at domestic dwellings, but this is commercial. But infinity doors are desirable whether they're on commercial or whether they're on residential. But they are, they really help to blend outside and inside. So they are very, very in vogue at the moment, and I can kind of get that. But what they're not particularly good for is keeping rainwater out, particularly at low level with strong wind-driven rains. They're quite prone for water ingress. So again, it's a case of aesthetics over practicality. And things, again, you've got that level threshold there. You can see it again on a slope. There's not a lot that's going to stop, a good rate head of water coming down there and causing you issues. Another quite aspirational aspect of a lot of buildings now, particularly where land is of short supply, is going underground, building basements. Now, it's a great way to maximize the footprint of your building. Very, as I say, aspirational. Now, the problem with basements is, by their very nature being subterranean, there is a risk of lateral penetration of water. However, it could be that when you dig your initial basement, that the lands are nice and dry, you've got no issues there. But we've already discussed the consequences of climate change. We know we're getting more water, we know water tables or levels are expected to rise. So whilst you might set your spade in the ground to start digging your basement and all might be wonderful and rosy, what happens further down the line when water actually comes to bear against the structure? Now, for those that are looking to design basements or want to include basements within their design, I would encourage anybody to ensure that their design includes the waterproofing to the British standard, which is BS 8102. And that tells us we should have a bit of foresight for these things, that we should expect water to come and bear against that structure at some point in its life. And you ensure that the provision for waterproofing is fit for that. So if you are designing, you need to make sure you get a qualified and competent designer that can do it to the relevant standards. But there is the risk that we have a lot of basements that have been dry for many years, haven't been designed and built properly, and as water table levels rise, that they end up being wet and problematic. And the problem with basements is much easier to waterproof right once from the outset than it is to keep trying to fix it, because that's where the costs really start to escalate. So preparing for the future. The one thing I think is important to note is it may be a perception that damp and mould only affects older buildings. I think we've seen through the amount of poor installs for ventilation, etc., that that's simply not the case. But we also need to make sure that going forward, our buildings are going to have to cope with more moisture loading, whether that be from moisture generated from the occupation or whether that be simply from water falling from the sky. Our buildings now need to be able to handle more water. As our buildings become more high performance, they will only ever perform as well as the weakest part. So if that weakest part might be a poorly installed ventilation system that doesn't comply fully with the building regulations, then we're going to end up with a legacy of damp and mouldy homes for the foreseeable future, unfortunately. But I hope this has given you some food for thought. I hope you found it interesting. Thank you very much.
James, thank you very much for that very insightful presentation and for joining us at Show Home Live. I have just a few questions I'd like to put forward to you, starting with what you think is the main reason why new builds are still experiencing problems with dampness and mold, because as you mentioned in the presentation, it is one of those things that we don't expect from a new build. I'm very glad that you did clarify that point, that, the fact that new builds do have this problem. What would you say is the main reason for a newly built property still having problems with dampness and mold?
Right. The one thing I didn't really touch on during that presentation, and I probably could have alluded to, was construction moisture as well. So the whole process of building a new build, there are a lot of wet trades involved. That might be reducing, arguably. There's still a lot of construction moisture, so that's going to take time to disappear anyway, if you want to say that. But it has to have the ability to be able to get rid of that moisture. You've almost got to foresee that you're going to have that construction moisture. And if that building isn't ventilated, regardless of whether the moisture comes during the construction phase or whether it comes when people move into occupation, that building has to have the ability to get rid of that moisture. So from my experience, it would be down to poor quality of installation for ventilation.
And when it comes to the fact that you said that we're creating more and more moisture, I'm just thinking about, for example, the developments that we're seeing in energy and water efficient appliances, tin taps, showers, for example. Are these not helping with the problem of dampness and mold?
I wouldn't single them out as the problem. And I'm going to say that we have one of the kitchen taps, the boiler taps, and we think it's fantastic. As far as practical utility goes, it's brilliant. Sterilizing guys, whatever. So my thoughts are, they're great for saving energy as well, which is another tick in the box. I think it comes down to how we manage that moisture. We've got to anticipate that we are making the moisture, but we've got to learn to deal with it. So the answer is not too dissimilar to my first answer. But actually look at the bigger picture. If we do it right, actually we can find balance between having those right appliances, ventilate that building right. It's not just about moisture production either, as I alluded to in that presentation. We need to improve good indoor air quality. So think not just moisture and the production of moisture, but the need for good quality ventilation to ensure that we have healthy indoor environments.
And just finally, James, I wanted to ask as well, what are the implications for house builders when it comes to, for example, they've just sold a property and let's say a family rings up to say that they've got problems with dampness and mold? Is the house builder going to be held accountable for those issues?
If there is a building defect, then absolutely they should be. If it's down to the ventilation not meeting the correct standards, or it could be that there's other inherent building defects such as cold bridges that should have been identified during the construction phase, then I think the occupant, the owners, the tenants, whoever they may be, should absolutely be able to go back to the developer and put that right. I think in reality, though, the problem with moisture is it's very difficult to identify the source as well. And in many of those situations, actually the blame would unnecessarily be put back onto the occupant and it's that horrible term lifestyle. And I don't think that's productive, because that's just a barrier to finding out what's actually going on. I've never come across a property where it's solely down to moisture production. There's always something else going on, be it sort of inadequate ventilation, whether it be a building defect such as cold bridges. So I think in reality, the thing is too often put back onto the homeowners. But I think if we are building these buildings and something isn't up to the minimum standards set out in the building regs, then absolutely the developers should be held accountable.
Well, thank you once again, James, for joining us and sharing that wonderful presentation with us.